Hello students, today I'm going to tell you something interesting. How to preliminarily calculate the thermoelectric quality of a material. In this lesson, the main purpose is to walk through the process of calculating thermoelectric quality first, and then the previous words are mixed with some, that is, two-dimensional materials. We will cover some very basic modeling concepts using this device studio. Let's briefly introduce the interface of this device studio first. The middle area is used to look at the structure of the crystal or device of this crystal structure. This can be used to simulate both crystals and devices, but here we mainly study crystal. Then this project on our right is a project on our left. From here you can select the model for the crystal you constructed. For example, Jianhao's model is this. Then what he looks like after the expansion is like this. And then if we perform input calculations on him, we first double click to select it to ensure that he is a selected state, and then click this simulator to select this Nanodecal, and then select this again. This is the calculation. For example, we have to perform an SEF first, which is static and self-consistent. Only then can we perform the subsequent calculation of this calculation. Then I will do this later. Speak slowly. Let's not talk about this for now. Let's briefly introduce this interface. Then here are properties, that is the crystal, including the gold grid parameters and atomic beams. Things are mainly some information about the gold package. You see, when I click this, it changes. That is, it can quickly see this. The total number of atoms is 18. This number of atoms is a reference for our later calculation. That is, if we deduct the package, the number of atoms should be around 100 as much as possible. Now, for the sake of simplicity, just start from 18. That is, when the garnishment is later, we will talk about how to expand the insurance. And then the following is such a state of the calculation task submission. If it is completed, it will be completed. That is, it has been completed. And then here is its project, and is this local path, and then you can choose it here. That is, this one with two computers is beauty, this one is a little bit, and this one is fine. Directly connect to the server of the supercomputer. Generally, the calculation objects we submit in this device studio are connected to this supercomputer for calculation. That is, the task is assigned to the supercomputer, and then the supercomputer is allowed to help calculate, and then the results are returned to our local area, and then let us perform further processing. Then the operation interface of this is a Linux operation interface. A basic command to check the status of the task is that SQUEUE will appear after clicking. This thing is empty because the calculation task has not been submitted now. If it is submitted, there will be more detailed information here. Then you can also use ls. This command is to view what's under this file in this directory, files. Then use the pwd command to see the location of the current directory. You can see that if you directly select this thing, directly select this, and then click this open put, it will directly connect to this path of this calculation above the supercomputer. Listener needs some basic knowledge of this Linux. Then if you want to manually submit the calculation assignment on the supercomputer, you can use this sbatch this command, then space, and then enter. For example, if I want to make a static self-consistency, that is, SCF point slem. After we mention this task, he will make a static self-consistency and can submit it for demonstration. Hey, if the submission is successful, a task number will appear. At this time, let's take a look at SQV again. Do you think this task is already running? Well, how to write this script. There will be a special small one later. A short video to briefly talk about this, how to write this script for submitting a task. You must have this script so that it can perform a parallel operation. This should be calculated very quickly and it should be finished at once. If you want to view more detailed task status, enter this command to show job. Show job, then there is ID does not seem to be. Wrong. It's S control. Show job and enter this job ID, which is this 2283285288285. Then, after speaking, we can see this more detailed information. For example, we can see that he was at which node. You can see how many CPUs he used, that is, how many scenes he used. And you can also see this. The calculated path. Where is it? That's probably all that needs to be seen. Oh, my network is disconnected, but don't talk about it. That Wi-Fi doesn't work very well. Then let's briefly talk about how to model a crystal. Click on this build. Subsequently, proceed to order this type of crystal. Clicking solely on this crystal allows modeling of said crystal. Conversely, clicking the device leads to modeling the device. Like what we mainly talk about is the modeling of this crystal. Well, if this is written in other people's literature, you can just fill it in and try it out. This is a space group, and then this is often described by Jingge. If it is P1, it means that there is no symmetry. In fact, I generally prefer to use this P1 for modeling. It has no symmetry humanity, because sometimes symmetry will be very influential, and this will greatly affect my operation. When deleting an atom, he deleted all the atoms related to the symmetry device, and the same is true when adding atoms, so I usually use this leather sock if I want to build this. Western graphite-like structures with resemblance to those found in Bentley. For this one-way trip of Big Violent Girl, you can use this P1 or what is mentioned in other documents, this and this. And then if you use P1, we can write it like this. This A is equal to March 12. Make this 2 and ensure it is done. 90. Close your eyes and envision March 12th. This is the C direction we need to focus on. Is the direction of the vacuum layer. Later, why did you aim to establish such a novel direction and integrate a true skill layer? It's permissible to discuss this now. Essentially, this act disrupts the periodicity of a golden pavilion within the Z direction. By proceeding this way, the vacuum layer infused with 20 units of ammonia and 20 I within the C direction becomes the sole entity. Misses is a two-dimensional material. This omission means it would lack this essential layer. His floor and the city establish connectivity. So if there is an interaction between Chang and the city, he will. He will undoubtedly experience a mutual influence. That is, after there is mutual influence in the z direction, it is not a two-dimensional material. Let's apply a green color to this area and then set the other section to 00333 for experimental purpose. I don't know, right? Set this as an egg. All right, the value is 0.6. The value 0.666 should be the alternative version. This is 0.666. That's 0.33. Take a look. Then just take a glance initially. He certainly is a type 0 character, but if there is an error, make minor adjustments. Oh, 66. Oh, that's right. How do you verify if he's right? That is... Hey man, what's the plan? Initiate this build process, then proceed by selecting the Redify Crystal option. Words. Our definition specifies Bristol, followed by identifying this particular location. The student's 3 representative means that the insurance has been expanded by 3 times, and then this position is also written as 3, which means that the expansion square is 3 times, that is. 3 gold bags were expanded along this direction, and then 3 gold bags were also expanded in this direction. Preview, you can see if it is a graphene structure like a graphene structure, and then you don't need to worry about the C direction because it is a 2-dimensional material. What we talked about just now is this vacuum layer. If we don't add this vacuum layer, he is the individual in question. And the upper layer, if his distance is too close, there will be interaction. It will affect him, and he is not a 2-dimensional material. You should know what I mean, right? Only by adding this impulse layer can the influence between layers be eliminated. We click directly on Build. This is also the package after the expansion will also be used. Now we have successfully constructed these 2 packages. We can compare it with the golden pavilion depicted in others' literature to ascertain its correctness. Because it stands to reason that a structural optimization needs to be carried out after the membrane is built, but for the device studio, for this nanodecade, its structural optimization is not very good. It is this relax. It often doesn't converge, so I usually use WASP or DSPO, this kind of software for structural optimization. We'll discuss this at a later time. I'll create a dedicated segment to talk about the structure optimization in detail. For now, let's focus on this. You have already obtained such an optimized structure. How do you evaluate it? Are the thermoelectric properties satisfactory? These 2 will serve as demonstrations, so you may remove them if possible. If we achieve a favorable result, we can simply drag it in, and it will automatically display next to it. Then we now click on this. This is a single package, like we talked about this. This is a single package. Select and subsequently click on the simulator. Next, select this nanodecal and then initiate the first step of all calculations, which necessitates an SCF calculation. It is static self-consistency, which essentially involves its initial parameters. Roughly, you don't need to change it. If you want to consider females, choose this one in the spin type. contributed spin, or is such a spin with an inclined foot? Generally speaking, it is to simplify the calculation if you consider the situation that magnetism calculates this contribution first. This negative 1 in 1 means that this is a self-complete plan rate for us. Positive or negative represents the direction you choose. Then we usually set it to 0.1 in order to converge faster, because now there are quite a few materials that will be set to optional. That is, the convergence rate will reach 1, so don't use its preset situation. Of course, the most reliable thing is based on other people's experiments. The result, or just set an initial value of 0.1 yourself, is generally a magnetic material. If this addition is magnetic, you can add this to the home word. Just choose the plan rate. You don't need to add this egg because it doesn't contain sub-properties. At that time, in our example, it is not magnetic, so note will do. Then establish this basis set. This is his crew file. We use LDAs. This exchange association is included, or the cross-linking association standard of this PP clothing is used to exchange association. As far as we can, choose the basis in the previous place. Settings, exchange correlation. Here we pick one. Season A bar PPE 196. Everything else will help you calculate the best one. If it doesn't converge, you can adjust it down or up by 1 point appropriately. It doesn't matter. Anyway, if you start calculating, just follow all his preset parameters without changing anything. But I prefer to change this. The season is also the same as PPE 96, because most of the text lines are made of this PP clothing, so the range of exchange views is more comparable, right? Others don't need to be changed. This is a pre-value of convergence. That is, in what range does the energy converge? This one is a calculated accuracy, a parameter, and then here are some things related to convergence. If the calculation doesn't collect points, you can change these things in general. It's not too outrageous. The structure or anything generally don't have to change these things. Then we see that this basis set has automatically changed it to this PPE for us. Exchange association norm function. Then when you choose here, you can click this generate files. I'm already here. It's been calculated, so let's treat it as already ordered, eh? Just click this generate files, and then we will find an SCF point here in the input file. This file is a lot of things when we open it. In fact, it is some of the input parameters we adjusted in the graphical interface just now, and then he generated an input file from it. And then how do we integrate that into the computation? It's simple, just right-click. Wait for me to get a bowl. Okay, just now I talked about how to put into calculation and trace this static self-consistent input file with input to be static, all input files. We chose this after we connected to the internet. We can open with first to check whether this parameter is correct. After checking, we can click run. Well, then select a supercomputer in this parallel substitution area here, and then here is the script file. Well, it may be nothing at first, and then we can import one. Script. Script. Let's choose this subbar SCF-PBS. Then after we put it in and imported it, we can see that a bunch of things appear. Let's talk about it a little here. How many boxes does this bar N24 mean? This is the standard beginning of a script file. Then this is supposed to utilize several nodes. Should you agree? Generally, we want to make significant changes, such as deciding whether to use 24 boxes or 48 boxes for this figure. You can simply modify it here. After this, we'll need to adjust the corresponding elements. How many groups do you want to divide it into? For instance, how would you like to proceed? Bar 24, our 2 bar 12 here, is also equal to 24. That is, it is divided into two groups. Each group has 12 cores to perform a calculation. This is MPI RAM. This is a parallel computing thing. Well, then this is the scenario. In fact, all of our script files contain the same batch of preliminary setups. The difference is that this... What is your input file? For instance, if I have computed this static self-consistent result, I want to compute additional ones. For example, if possible, I will change the SCF point input to the input file that can be incorporated, which translates to the band structure point input. Then after confirming it is correct, we choose this safe point, this safe. Subsequently, a prompt indicating a successful safe operation appears here, and then we click on Run. After clicking Run, the outcome becomes visible here. There is a state, and this status is Q, that is waiting in line. Undoubtedly, we should go ahead and click this process to examine the scenario where it gets calculated. In essence, this represents his convergence situation specifically for each of these 1, 2, 3, 4, 5, 6, 7, 8, 9. The meaning of running a few steps, then how much time it took for each step, and then this. This particular case of convergence generally involves this Hamiltonian matrix. In this convergence case, this is the total energy of his system. Generally, such an occurrence takes place. All the calculation has been finished. It means he's done. Then next we can proceed to the next step. Well, it's operated. Why is this for? I'm not quite sure either. This just updated. How might this be utilized? Assuming the calculation succeeds, it typically aims to complete the competitive process effectively. Once this static character is finished, we can initially examine the material to assess its potential appearance and properties. It's still the same. Just click this to select it, then click this simulator, then click this Nanodcal, and then there is no need to select this static calculation at this time. Let's click this analysis. Then after clicking, there will be such a bunch of things that are some things that calculate this material and analyze the performance of this material. Let's choose this band structure and click this. Can it be dragged or relocated? If dragging isn't feasible, utilize the arrow to shift it. For deletion, repeat the shifting process. Proceed with moving it now. Or a double G will do. then this is the high symmetry point, which has automatically generated us here. You can see that it is the path of GMKG. We right click and drag it, and it drags it over. It's this path. This is such a shape in the inner area of the first part, and then he chose the path of high symmetry point, which is gamma point to M point, then to K point, and then back to this path. This observation. Why opt for this method? It encompasses elements of solid-state physics. Succinctly articulated, it simplifies the concept. These highly symmetrical points are quite representative, so we need to calculate each geometrically aligned position with precision. Such a path of energy band. Then it basically reflects the whole. The property of such an energy band of materials. Anyway, there is generally no problem for him to use what he automatically generates, especially for two-dimensional materials. And then this one is a total number of points on the path. Well, for example, this. This path is segmented into distinct sections, point to point M, following point M to point K, and thereafter to point Y. Each of these three segments encompasses a combined total of 200 stepping points. Naturally, each segment approximately comprises 5 or 60 steps, which estimatedly remains consistent, since regardless of the height attained, the derived energy band remains unchanged. Thus, I stipulate. Anyway, look at the number of paths. Broadly speaking, simply multiply the quantity of permissible entries by 50. There is no problem with this 2 million, and then click this general files. Afterwards, this emerges. Examine the band structure electric input by clicking again to verify the previous configuration without altering it. That's it, and then it's the same thing. Just order this run. Then at this time we can just change this band. Then school. Then click save. Then just order a run. Then structure, and then after the calculation you can click this download button. We can directly download this band structure point XML file. Of course, this can only be said to be a rough view in the device studio, but if you want to draw a better picture with structure, you can. Download this file that falls into a point map and then put it in MetaLab to draw a picture which will look better and better. Now I download this band structure and click this download to download it. After downloading, the XML file can be found in, and the same is true to see it here. Use the right click. Select it and click this show view. You can see its approximate, what does the weighting structure look like? You can see that the top of the rack belt is at point K. We can order this top of weather span. Well, you can see that it is probably at this K point, and then zoom in with the hand mark to see its approximate, how thin can it be. Well, metabolism is negative as much as it is 167. Furthermore, IX approximately 167. Bottom knob of conduction band. 167 plus 168 equals roughly 3.35, about 3.35, approximately 3.34. However, more comprehensive information can be found in that document. Open the MATLAB file and examine its contents, and you'll have a clear understanding. Labels. Well, actually, we're here and discussing the theme of conducting scientific research, which is quite acceptable. It's innovative, it promises to be more user-friendly. You can opt to adjust the minimum X value to 0, leading to the preset configuration. There should be precisely 201 data points. If this gamma point is not visible to you, it may be suitable for 202. It is beyond view. Hey, from 1 to 202, all the components are weltered. Returning to this specific position within the Fermi energy level, let's select a color we find appealing. Go deeper. Bring up some. Hey, it looks immensely better this way. Then this font is better changed to this new Roman one. No, that's the title, isn't it? The title doesn't have to be that big. Egg's neighbor. Why can't it be changed? If it's impossible to change this, then you still absolutely have to use metal. It's quite troublesome not to change this, but it's actually okay, isn't it? You can get a picture in this way. Save plots that can be biased format. Well, or a little ugly. Whether this lesson is mainly about love, the same is true of this tie density. Density of state. In regard to tie density, the sampling at its K point tends to be significantly higher than that. 2210 when performing thorough static self-consistency. One definitely needs to be higher. Let's set it clearly to 25. And then here, it's the same. It's in the specified range from 10 to minus 10. Every 0.05 interval is taken as a point. 0.05.0, 0050.05. In a store in the electron volt area, the last point taken is 401 points. If you want to sample more densely, change it to 801 points. In fact, it is generally between 0.05 and 0.02. This is enough, and then this is projected. Such a projection can bring the projection probe density. But generally, well, and avoid drawing this thing. If you want to analyze which atom at the top or bottom of the head contributes more, you can draw this projected energy band diagram by atom or orbit. Then click this general files. After that, let's check this. If the book file is correct or not, just check this parameter a little. If it's correct, we proceed directly. Then adjust this band structure to density of state. Then order this safe. Then proceed to click on the RAM section. The image you have downloaded is ready. We remain unchanged. Simply opt for this location and click the download button situated below the action step, attaching the dance tail indicating the current status. Download the positioned XML file to your system. Upon completion of the download, we can similarly proceed by right-clicking the show view, unveiling an array of energy bands. Observations reveal a distribution linked to the auditory energy concerning tire density. Because I selected the parameter I selected in this example, which is -5 to 5, and then the sampling point is 800, which is equivalent to the improved accuracy, which is 4 times higher than the modern value, and then the calculated energy band is like this. Oh no, you can take the mouth. It is to probe the density. In fact, after completing this static self-consistency, you don't have to calculate this energy band or tie density. You can do it even if you perform the following operation. That is, if you simply want to calculate this, the thermoelectric performance is the Z value. This is the performance of a single package that has been calculated. Next, we have to look at the package expansion. The performance of this phonon. Well, how to thin it, as I said just now, just click this build. And a bit of this redefined crystal. Then generally speaking, at least 3 of this bag is needed. It is necessary to expand the package at least 3 times to ensure this. The calculation results are stable. Let's place an order to commence the build. Results will follow upon successful completion. Customs have now emerged. Quite a situation. Super bag. Then this super package is the same. The first step is to calculate this static suicide, and then here, try to choose the same parameter as the previous parameter when calculating a single package, except that the sampling that can be clicked can be different. Because the more densely you spread this K point, the credibility should increase considerably if the package is expanded, thus enhancing its value compared to the disguised version. The precision of this calculation is crucial and therefore important. You can light the sampling and reduce it accordingly. For example, we just expanded the report by 3 times, so this K-point sampling can also be reduced by 3 times, which was originally 20 and could be reduced to 7. This can be sampled by points. What's usually considered an appropriate value? Based on the amount, for instance, if the gold length of my single package is 3.12, you should multiply 3.12 by the corresponding N1, which typically ranges from about 60 to 70 or higher, reaching such a level. As evidence, the Golden Pavilion often mentions this post-package expansion. Letter A. The measurement of this historical quantity in the AA direction exceeds 9.37. After multiplying it by 7, the result approaches 65, which is a comparable value to the current figure being examined. Then, as I just said, try to be consistent with the original one and try to keep all other parameters as much as possible. Just the same as before. Be consistent when calculating single packages and then click this Generate Files. It's still the same. Just click this Run and perform this static self-consistent calculation on it first. STFSay function. Once Rob completes his calculation, he proceeds with computing the Hessian matrix. This matrix represents a crucial aspect in the simulation, followed by analysis of the nanodecade and subsequent scrutiny. Reorder this passionate enthusiasm. I must modify the parameters here, adjusting this to 0.01 and subsequently altering that to 3. This adjustment will result in improved accuracy and facilitate easier convergence. Then just click this Jennifer Files. After executing the click command, an input of such nature will be formed. But this cannot be calculated directly because it generates this by default. Let me show you. A set of parameters for his default upgrade is wrong, so after we generate the file we have to change it. We can see his line. Calculation, primitive salvators are the original package of Jenga history. However, it was found that what it automatically generated was not the amount of golden kudzu stone in the original package, but the amount of golden kudzu stone in the excess package. So the place to change was this place. How to change it? It is changed to the corresponding one. This group is to double-click the single package, and then these 3 ginger appetites appear. We put it... Modify the text here, for instance. Alter this to 3.05970. 0, then this is changed to ER 1.561855. Error, this is the same, and this is changed to this 2.707175. Oh, this is what it looks like after the change. After changing, click this to save. At this time, you can click this Rob is the same, change it to here. Save. Next, click this Run button, and in general, this Hessian matrix will require a longer computation time. This calculation depends on the dimensions of your super package and several of your convergence techniques, especially if convergence is significantly delayed. You can consider it that's change some of these parameters. Alternatively, seek employment. I'm asking what's going on. But if the Marine Life Bureau recognizes the calculation, if it is a relatively large system, generally speaking, the convergence takes over 10 days. Calculating within 10 days proves challenging, hence an additional line is necessary here, like this one. Planning a TI journey, this single parameter suffices. Let's observe the appearance of this output, as the default lacks this parameter, rendering us unable to like. When looking at the static support calculation, how much time does it take each step? This particular message is shown. Therefore, there exists a parameter, but its specifics are forgotten. I'm going to include it later in the presentation. Given that I can't recall it currently, I'll pass over it for the moment. Subsequently, after an extended period, the marine formation is complete. Proceeding to the next phase is required. Let's count something related to phonons, such as this phonon spectrum of phonons. Southern Puman also selects this banknote package and clicks this simulator, then clicks analysis, and then selects this. Follow band structure. This path of this nuclear energy belt depends on the alignment points. Just click on this general files directly. The same is true after clicking. That is, first look at the parameters to check if they are correct, then click run, and then change yourself to this change to follow and strike. Is it safe? Then click run, and then after the calculation, we download the folder band structure XML. It's something like this, 1234. I need to change it a little. Generally speaking, it is. If material, if its single package has only 2 atoms, then the number of its birth spectrum is. Multiply the number of atoms by 3 and you see that there are 1,234,566 items here. If you look up, there will be none. I really set it to 200 and it will be all empty when it goes up. Oh yeah? And then the bottom 3 are usually clicked from Y. These 3 general lines, we generally call them entering the school, and the ones above are all optical light, so learning is relatively smooth. Then, relatively speaking, Sheng Xueji has changed a lot, but this strange thing is his, which is interspersed with the optical branch into the biological branch. If there is no continued review of this place here, or there is a slight false review near comma point, we can all regard it as a stable material. What kind of situation does it need to be different? That's what it will have. In this area, a thread of 90 will exist, indicative of a reasonable expectation. What needs to be commented on means that the Q line is less than 0. For example, one of it may be concave from here, boil at the position less than 0, and then come up again. This is also considered Shuping, but this nanodecade calculation, he returns this virtual frequency to 0, which is negative, making it all equal to 0, so it looks like. As long as there is a horizontal line on the bell, it needs to be leveled, so it may be unstable, but it needs to be leveled slightly. It can also be regarded as stable because it is possible for two-dimensional materials to be stable in calculation, but there will be a little need to be leveled when giving birth. How to cut this need to be leveled? Generally, it can be done by expanding a larger package or ER or using a more stable structure. For example, when optimizing the structure, its convergence parameters are used. Lower it further. Then a more stable structure is obtained. There is also a larger package. For example, we are 3Ac3. We only expand and thin it, and then there are only 18 atoms. Then we can expand the larger package. I will expand it 5 times, 6 times, and 7 times. Watch out for the unexpected twist. Alright, let's broaden it to include 72 atoms. Actually, there are 72, which is actually not too long. Generally within 100 atoms. It's not very time consuming to calculate, but it's more than 100 atoms. Generally speaking, it takes a long time to forget it. You may wait 10 days or 8 days. The result didn't come out either, so I said, this number of atoms is also a problem to consider when calculating. Well, he lacks the current birth spectrum we possess. Virtual flat subsequently proving this material's stability, allowing us to proceed with the next calculation, thermoelectric quality evaluation. Let's review first. We first calculated the static self-consistency of the telecommunications energy of this single packet, as well as some things about the energy band and tie density. Then after finishing this, we expanded the packet and expanded the packet for the static support, after a calculation of this Hessian matrix is completed. We can get the birth spectrum. After we get the birth spectrum, we can formally calculate this thermoelectric grease. This is also selected for the calculation of thermoelectric grease. Post-insurance expansion, proceed to another decade and initiate analysis. Then after selecting this ZT, we can see here there are many parameters, so we choose this one, the location of the original package, but we are unaware of this round bag's location, but can infer its position. We can familiarize ourselves with some basic knowledge of Linux, that is a little bit. Dot bar means navigate back to the Pole directory. This is the catalog on Awesome. You can't choose here, you can't choose here, because you are the directory of this machine. But if you want to choose supercomputing, you can only use this relative path to choose, or you can just go directly, click this and choose that PWD to see where his absolute path is. Now we can use this relative path directly for convenience. I'll tell you how to get there directly and see where this path is. Well, first of all, it's his. The directory structure is as follows. Suitable, the structure on supermarkets is the same. Thus, we can click on this and allow it to expand. Then choose this analysis and click on this ZT. After that, click the bar, which means returning to the superior from this position, and then return to the superior. Now we are in this directory. The superior of this directory is, so now we have to enter the directory name of this ALN bar, MLALN bar. Next, let's enter this. Nanodcal crystal. Oh, no D care. A remarkable crystal formation has taken place. Well, after that, I simply articulated the statement. This static self-consistency must be performed, but after the static self-consistency, a file will be generated. I didn't tell you just now that this file is the basis of all calculations. What is the file that stores basic things for calculation? That. Nanodcal. Object. Documentation files. And this file. Let's write the specified path correctly and then review it. First play 2.bus.bus. Next, we'll denote this path as a len. Bar ML followed by nanodico crystal formation. Then this is generated after he does static self-consistency. 1. A file, just the basic file. You can recognize it because all the calculations are around this nanodecal object calculations, and then it's done here, and then this sampling that can point, we can just step higher. It doesn't matter, 25, 25. This is K, which is the one in the space of the electron, the one looking for space. Only when you click it, then this Q point is the sampling point in phonon space. We all try it to be 25, 22, 15. Then how to choose this energy range? If you want to go back and see this range that can be taken, it must include the island belt top and the rack belt top. For example, we looked at this material before. The top of the rack is about 1.68, and then we must include it, so we can choose 2 or 2.5. Choose 2, choose 2.5. It doesn't matter if you want to love. And then here we see the one just now. The position at the bottom of the island bag is at about 0.68 electron volts, so it must be included here. Isn't 2.5 just the range from 2.5 to 2.5? Did I include the bottom of the guide belt and the top of the frame belt just now? And then this is every how many? Just take a point for electron volts. Generally, this default is enough, and then you can change it here. Look at this material in detail. Where is the suitable temperature range? It appears that myopia seems to be mainly related to this. According to the Debye temperature, it is such a parameter. Is it applicable to such a scope? After exceeding the Debye temperature, there may be some errors in the calculation results. For this material, the temperature in Debye can reach 7 or 800, so you can choose 700, specifically 700K. Then you must pay attention to this direction. The 3 directions are for materials. In the C direction, which is the direction of the Z-axis, and then in this direction. We're talking about no periodicity. Because we have added a vacuum layer, we cannot choose this 3 direction. We can only choose this 2 direction. In fact, the first and second directions are the same. This is true for this graphene-like material. If it is adopted, such. Earlier, I saw the single bag with the quadrilateral shape. If this kind of bag, 1 and 2 directions, it is both. In the actual direction, it becomes a zigzag path. So this 1 and 2 are the same. If you want to calculate the direction B of the handrail, you have to rebuild the package that you want to calculate is the idiomatic package. I won't be teaching you the method here. This package is enough to teach you how to calculate this thermoelectric quality first, and then these materials, these parameters have actually been prepared. Let's just generate files. Next, we verify the identical OpenWS. The 2 directions are okay. You can see the calculation city system object. You can see that the front one is the position of the electron, and the back one is the position of the phonon, the position of the calculation file. If you click the poll, it is the current directory, that is to say the nanodecade object file in the current directory. That's all I carry. Provide some essential details about the material, then click Save, proceed to submit the task. It's also run. Simply switch it to ZT here. Save. With this, just mess up. This passionate love demonstration requires a considerable amount of time to calculate, occasionally taking longer than a sea cucumber to provide proof. It's mainly based on your adjustment. This density of the interval has something to do with it, and this, as the range increases and the interval decreases, it will take him a significantly longer time to compute. Afterwards, once completed, we remained unchanged, simply clicking in and downloading one of their files. Here you can directly observe to get a general understanding. Choose this chemical potential. Then let's look directly at this CT. Well, you can see him in